right, hi guys at home. Zoom out real quick. Basically, what we're doing today is we're taking down an anchor chart on the 4 different types of wind. And so divide your paper into quadrants, and then we're going to focus on the first quadrant first. All right, the first type of wind we're going to talk about is the prevailing westerlies. They blow from the west. So what I want you to do is I want you to draw America. All right. And you know that Miss Ross is not super good at drawing America, but we're going to try. Bring it down like this. There's Florida, a little bit of Texas there, kind of comes up like this. All right. There's America. This is where you live in North Carolina. America is a temperate climate. Okay. We live in the temperate region. And in America, the winds always blow from the west. Starting at the west coast, that's California, to the east. Do it again. From the west to the east. Those are called the westerly winds. They go from California. California is where the governor lives, Governor Schwarzenegger. There's California. California. And then this is North Carolina over here. So the winds blow from the west coast to the east coast across the nation. I want you to write this. Whee! Because they blow from the west to the east. They don't say ew. They say wee. Got it? Okay. All right. West to the east. All right. Let me take down, I got to go over here to get my notes from my first class. West to the east. All right. So let's write down our definition. Winds that move the weather in the temperate region from west to east. Here we go. These are the winds, and there's several types of winds. These are called global winds because they travel the whole globe. The winds that move the weather in the temperate region. That's where you live. You remember we talked about y'all have like the Goldilocks climate. Not too hot, not too cold. Moves the weather in the temperate region from west to east. So like, for example, you know that like we live like in, let's say Raleigh is here. Well, if it's raining in Raleigh now, the rain moves like this and it will be in Gville later because the winds push the weather from the west to the east. Does that make sense? Now, that's not, 100% always the way it works. If there's a hurricane spinning off here, the weather's coming in this way, right? But typically it's traveling from the west to the east. We're going to write this down. In America. We love America. Everybody say America. America. Very good. In America. The westerlies, they call them the prevailing westerlies, move the weather from west to east. And then I want you to write from the west to the east, not ew. Wee. Those are called the westerlies. We call the westerlies, this is important, they are the gas pedal. Gas pedal mean they are pushing the weather. Like that's what's pushing the weather car forward. They are the west, they are the gas pedal for weather. They push it from the west to the east. It's the gas pedal. All right. We'll slide this over to next type of wind. All right, this one is a little bit more complicated. This one is called the jet stream. Jet stream. Hey, Jaden, does a jet fly in the air or under the ocean? Very good. I want you to draw an airplane up here. This is an aeroplane, and don't make fun of my airplane. Oh, Miss Mo. He would make fun of my, he would say, Miss Ross, I won't make fun of your airplane. All right, this is my airplane. All right. Ooh, that's bad. Okay. I'll put a door on it. Okay. This is a jet stream. Underline jet and point to the plane. And the reason why I am putting an airplane here is because I want you to know that it's fast moving cold air high in the sky, in the atmosphere. It's like a, it's kind of like a little tube of cold air, like a river of cold air up there. It brings cold polar air to the westerlies. All right. And we call this the steering wheel. And I'll explain that in just a second. Just get this down and then I'll explain what that means in a second. It's high up in the sky, like flies like a jet. It's like a river of freezing cold air. All right. I'll come over here and I'm going to do my best to draw America again. All right, here's America. There's Florida. There's Texas. That's so bad. Okay. America. Now, y'all know that the westerlies are blowing across America just like this, okay? Draw the westerlies in. And you can even label these with the westerlies. They blow from the west to the east across the nation. Whee! Now, the jet stream comes like this, and I'm going to draw the jet stream blue because it's cold air. Jet streams also blow from the west to the east, but they kind of come in from like the northwest. So they kind of come in like here, and they come down like this and go like this. And when the jet stream comes in, it brings cold air. It brings that jet stream brings that cold air down with it. So this is the jet stream. And when it brings that cold air down like that, then the westerlies can kind of like move up or down, and the cold weather can come. Hang on, don't get angry. The cold weather comes down with it. Okay. So all of this is cold, 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 cold. And so it brings this cold polar air down with it. Now, how far it dips down determines how cold it's going to be like in Florida. Okay. So I'm going to pause this and then I have a video to show y'all. I have something to show you with where the okay, I just showed them a website where you can go to look at the jet stream. And we saw that the jet stream currently is running about like this, and it's pulling down that cold air from the Arctic. Okay, so here we go. Draw like this. The jet stream brings cold weather. South. So if the jet stream is running way down south, then it's going to be cold. If the jet stream moves up, like if it moves up like this, the cold air is going to stay up north. But right now, the jet stream is dipping down into here, and we're getting that cold, cold, cold weather. All right. So we got the westerlies moving it from west to east. Notice how both of them go from the west to the east. Okay. No, ain't nobody going the other direction. They're both going west to east. All right. Now, our next type of wind is a sea breeze. So I'm going to draw this. I'm going to draw this, and then I'm going to label this section right here sea breeze. Okay, a sea breeze blows from the sea. Does that make sense? You're a Greenvillian because you're from Greenville. You are an American because you are from America. You are an earthling because you are from Earth, okay? You are a wintergreen gator because you are from wintergreen. Okay, so this is a sea breeze because it comes from the sea. Make sense? The name is where it comes from. My people are Irish because we are from Ireland. Does that make sense? Okay. You get the name where it comes from. All right. We're going to write the definition first. A sea breeze, it's a local breeze, meaning that it doesn't go all over the globe. Sea breezes happen at the beach. It is wind blowing at the beach. At the beach. Or at the coast. Does that make sense? From the sea. Now, all of you, I'm sure, have been to the ocean before. And when you are there, it is almost always windy. It's wind blowing at the beach from the sea during the day. Wind always, this sea breezes are always during the day. And then I'm going to draw y'all a picture. All right, we're going to come over here. I'm going to draw the land. All right, this is the beach. I'm going to make a little sand castle. Look, there's my little sand castle. Look, there's my sand castle. A little flag on it. Okay, there's my little sand castle at the beach. I'm going to put the ocean going up to the beach, just like this, because y'all know how it rolls. Did you finish? Yay! Good. Don't hit my coffee. I love you. Good job. Now get on your notes. All right, here we go. So what happens is I told you that this happens during the daytime. Draw your sun up here. Sea breezes happen during the day. And the reason why they happen during the day is because during the day, the sun is heating up the land and the ocean, right? The rays are coming down, they're heating up the land, they're heating up the ocean. But the thing is that the land heats up faster than the water does. Okay. And that is because dirt and rocks and ground heat up faster than water does. It's just part of its nature. So what happens is the land starts to heat up, and we know, does heat rise or sink? Good, heat rises, right? Those convection currents start to happen. So the sun heats up and the heat starts to rise off the land. Well, then a convection current happens. And then you know that heat will rise and then it'll hit the atmosphere. It'll turn cold, and then the cool air will do what? It will sink, right? It makes a convection current. So the hot air rises, the cool air sinks, and then that cool air rushes to shore, just like that. So the reason why you get a sea breeze during the day is because the land heats up faster than the water, creating a convection current. So the wind goes like this, whoosh, and blows in with that cool air. That cool air whooshes in. So you go from high pressure is replaced by low pressure. So high to low, get a whoosh of wind that blows to shore. I'll write that here. The cool air rushes in. It rushes in towards land. Can I zoom in on this a little bit? The hot air rises off the land, creates a convection current, cools off, and then whoosh back that way. So that is why you get that. That's why you get that cool rush of air moving ashore. It creates this constant cycle. Yes, Molly? Kind of like the water cycle. Yeah, absolutely. Okay. So when you go from, write this down here, when you go from high pressure to low pressure, that's when you get the whoosh, the hard blowing winds. And I've taught you that. You know, when the pressure goes low, the weather gets lousy, right? You get windy weather when it goes low. High to low, whoosh. All right. And all of this happens because the land is heating up faster than the water. So let's write that down. Sea breezes, that's at the beach. It's always windy at the beach. Sea breezes happen because the land and water heat, they heat and they cool unevenly. The land does both of those faster. Land heats up faster and land cools off faster. They heat and cool unevenly. So that high to low whoosh creates that wind. And don't worry about it. I'm going to tell you that about 97 more times before you take your science EOG at the end of the year. It'll get to the point where I'll say, what causes wind? And you'll go, because the earth doesn't heat evenly. And I'll go, yep, that's it. But this is just kind of to start you off. Do you know what I mean? All right. Now You learned about a sea breeze, and now you're going to learn about the opposite thing. I'm going to zoom this out. That's right, baby. Land breeze. Draw this. And the fourth thing the fourth kind of wind today is a land breeze. I am Irish because I am from Ireland. This is called a land breeze because it is from where? Very good. From the land. It blows from the land to the ocean. You are American because you are from America. Very good. All right. From the land. So it's going to blow. This is wind that blows from the land to the ocean, to the sea. And guess when it happens? Well, if this one happens during the day, this one happens good during the night. If you were to go to the beach at nighttime, the wind would be coming from behind you. Do you see what I'm saying? Like if you're staring out at the ocean, the wind will be blowing from behind you. All right, we're going to draw the same picture. Draw the land. Draw the little sandcastle. There's my sandcastle. Only now it is at night. So draw stars up here and draw a moon. Look at there, Harmy. I made you a moon. There's my moon. Okay. All right, so it's nighttime now. And at nighttime, the land cools off super fast and the ocean doesn't. So the land has gotten very cool. The land has cooled off. So now the heat is coming off of the ocean. So the heat rises off of the ocean now. It was coming off the land, but now the water is hotter than the land. Same thing, you get that convection current, it rises up. The cool sinks. Just like this, you see the swirl? Everybody see the swirl? Heat rises, cool sinks, and then whoosh. Now the wind is blowing Attaway. It rose off the water, the heat rose off the water, sank when it cooled off, and then you've got your high pressure to your low pressure. Whoosh! And now the wind is blowing towards the sea. The wind rushes to sea. Miss Ross, this is too cool. I know. But again, the process is the same. High pressure to low pressure. Whoosh. Whoosh. High to low. Whoosh. That's it. I'm zooming in. It is. Keep writing. You're doing good. Uh-huh. And we're going to freeze right there. We're back. Sorry, we went to recess. All right. So for our sentence here, we're going to write land breezes happen because land cools faster than water at night. So when you see this on your EOG, it's going to say something like, what causes wind? And it will be, and the answer is going to be, it's going to say it weirdly, but it's going to say differences in land and sea temperature, or differences between land and water temperature. That is what causes wind, because you get that high pressure to low pressure and whoosh, the wind rushes in. And because the earth heats unevenly, the water and the land part, they heat and cool unevenly. It's called differentiated heating and cooling. I did, Jaden. I did. All right. So make sure, I'm going to zoom out on this. I'm going to freeze this, and you guys make sure that you have all of this written down. I'm going to walk around with a comprehension sheet for this evening.